tell you a little bit about myself. I'm Senior Android Innovator at Home Depot. I work on a lot of different stuff. I'm the Women Techmaker Lead for Dallas, Six Sigma Blackbelt, Intel Innovator, bunch of other stuff that you don't really care about because you're here to learn. You don't care who I am. Come on. But there's some contact information and things like that in case you want to ask me further questions or throw me extra tips and tricks. I'm always up for hearing like what kind of creative solutions worked for you. So here's some of the biggest issues that we face with mobile networks on applications. Large, unfiltered images. Your API is servicing you stuff that's meant for desktops. It's not meant for tiny screens. But you have tiny networks, so you need a way to make those things tiny, right? So we also have issues with untracked data usage. Do we really need to be constantly hitting our like usability API when the user's not actually using the application? Do we need to constantly be tracking what they're doing while it's not even active? Probably not. You can have non-optimized network handling. So are you putting your batches of bundled data together, or are you just constantly hitting it whenever you want to? And just bad API designs, not using the Android tools, and one that's pretty awful that I see fairly often, doubled API calls. Why do you need to try it twice? And it's one of those things that can be hard to figure out if it's happening or if it's not. So I'm going to show you how. So how do you track your application data? You can use the Android tools, which Google has been really great about giving you instructions on how to do that. But there's more stuff out there. If you're watching for your APIs and responses, I strongly suggest that you use something called Charles Proxy. It's not free, but it's worth it, especially if you need to check, are you sending the correct API data and are you getting the right return data? Is your stuff formatted like it's supposed to be, or is it kind of jumbledy? Now, I'm not going to cover that in this discussion. I'm just giving it a props so that you guys can actually go and look. There's a ton of great information already out there for Charles Proxy. So we're going to be talking a little bit more about detailed tracking of network data. Now, we've all probably heard about Wireshark, but you probably haven't heard of something called the Application Resource Optimizer, which is commonly known as ARO by AT&T. And it's the easiest thing for you guys to use who are not used to tracking stuff down by looking at, oh, this packet had XYZ. Let's kind of go into that a little bit. So we're just going to say this is how you capture a PCAP, which is the file that's actually used to insert into the tool. And this is where I kind of say having a rooted phone for development, at least one of them around, is always super helpful because it's a lot more of a pain in the butt to get the same information from a non-rooted device. But you can see it's pretty easy. What you do is you basically stop all your other applications from running that are not part of the core services and just run your application. And while you do that, you make sure that you have this file being generated by TCP dump, and then from there you just copy it off the device after you've done what you need to do. And you got to specify which kind of interface you're using. So are you using Wi-Fi or are you using cellular networks? So you'll actually see that if you do like an IP-ADDR. That way you can see, what network interface is actually active and what are you actually using. So download and install. I think you guys can figure this out, but this is more just for reference material. Again, these slides will be available after this discussion. So what do you get once you put your file into this magical tool? Well, the first page gives you this lovely summary of exactly what is good and what is bad. And what we can see here is, hey, I've got green check marks across the board. Everything looks pretty good. There's no major flaws. There's no major issues popping up. This is kind of a dream situation. Now, granted, we could do a little bit better on that trace score because 663 out of 1,000 isn't amazing, but it's giving us, hey, we have no major flaws, no major issues, and if you are just making sure, quick glance, you maybe added a new feature, you can pop it into here, go, oh, everything looks cool. All right, that's my smoke test, all right? So let's just say there's a blue competitor that wanted to track our stuff against to make sure that we were kind of ahead of them in the retail industry. I think it's kind of implied who that might be. But just as you can track your own data, you can track your competitors' data too. And you can track exactly how good they're performing and where you're actually going to be able to even learn from their mistakes and be able to figure out what they're doing right if they're beating you out in certain areas. So what's something that we see kind of going wrong right here? Now I understand the actual text is pretty small, but we can see that, oh, there's not good cache control. That means there's not cache headers on some of those assets that are being pulled in. We also see that, hey, maybe these images are pretty big that really shouldn't be happening. Now, for both as a comparison, I performed the exact same search on their app as it was performed on mine, and then also tapped on an item after the search, fully loaded the page, and made sure that before doing so, we loaded about 100 search results. So this is the exact same data in terms of user interaction on both sides. So we also see that, oh my gosh, they're not minifying any of their JSON, CSS, stuff like that. Not just like any, but you know, there might be an issue with one or two things. So, this is what it looks like if you scroll down on that summary and you have an issue. It'll be a nice big red box that tells you what is wrong and maybe even how to fix it. So here we're saying, we just tested, it doesn't look like you have the presence of cache headers. Now, that could be an issue down the road, because what if somebody needs to go back to that resource, or you have another thing that uses that same resource, that has to be re-downloaded. And that can be a pretty big thing. So why would you do that to your user when you're within the same session? I can understand getting rid of it after the session's over, but you're still there. So why not hold on to it? So here's the other issues that we saw. And this is where it kind of gives you that information. And you can see I've blurred out any of the, people that might be involved. So you can see that the images are a little too big. These were the images that it pulled up. These actually looked to be desktop quality when I actually went to those links and looked at them, which can be really nice if you have a very high quality device. But I was testing on a couple of different devices, and some of them were not high quality devices. So it ended up taking up a lot more space with actually no positive outcome from it, right? And again, the minify of all of that, you could have saved 7% just by getting rid of empty spaces. 7% of that whole string could have been saved. So what's another cool thing that you can do with this tool is you can actually dictate your own profile. So if you wanted to track something that was maybe a really small network, you have a certain set of parameters that you're exactly trying to meet in a certain set of conditions, you can actually tell it exactly what you want to have happen. Is your target, okay, I only want to use like 95 millijoules of energy to perform this transaction. Am I good or am I not? So this can actually give some of that information inferred based off of knowing how much power is used by the radio. And you can actually set that so it makes it really easy for you to test this in the future. So here's kind of an overview of what our data looked like. So it's showing a lot of unknown. Now, normally it would show a lot of like images JPEG or images PNG, but we're doing some things to kind of obfuscate some of that and do some actual data batching to make that a little more efficient. So it's not going to be immediately recognizable that, hey, that's a JPEG file. But you can see, you know, doing a lot of search results, we got a lot of JSON requests. And we can see, hey, it moved pretty fast. We weren't using a crazy amount of data. And that it generally looked pretty good, right? Now, if you're familiar with Network Monitor, the diagnostics are going to look very, very similar. So we're looking at this from a forensic point of view, and you can see exactly what happened when I was going through various points. So when I first load it, that's the gray. Then we have the first burst of the big red, which is me performing the search. Then there's some little dots for loading extra search result data when going down and scrolling more and fetching and getting that stuff in. And then you can actually see, oh, when do I actually tap on an item, and then I tap on an image of the item. So I got to the image page, and then I tapped on the big images, right? So you can see exactly what that was, and what was the amount of time that I was actually using what they call RRC. Basically, it's how much radio time were you using. Was it a lot? Was it at the whole thing of the bandwidth at once? And it really wasn't. You can see it was kind of yellow and kind of green. And when you're dealing with an immediate user interaction where you are the forefront application, that's actually pretty awesome. Because quite a few of them will run very, very red to do the same kind of thing. And you can also see at the bottom that you actually get, what ports, what were your endpoints, what traffic was going where, and how much of it. So we have a statistics page as well. So we actually get to see how big were the packets that I was sending, how long did it go, how fast was I running, and what's kind of my score? What did I do really well at, and what can I improve at? So in this case, I really could improve a lot on my tightly grouped connections. So holding one connection and then not maybe having a whole bunch of different server requests of a bunch of different endpoints would probably increase some of my efficiency, right? I know it's hard with external libraries and things like that to kind of make that work, but it does give you some niceties down the road. Now, also signaling overhead. That means I had a lot of headers, I had a lot of other stuff, and things like JSON, certain API requests that I could improve on, right? So now we get down to something that I am super passionate about, all right? Compression is your friend. It is always your friend. It is never not your friend, unless you're doing encryption too, but that's a whole different thing. Filter your images, people. Filter them. I am so sick of seeing 40 megabyte PNG big photo downloads that have no reason to exist on a mobile phone, even if you're doing mobile editing of the actual pictures. There's no reason for it. So why not use something that's going to be giving you the exact same experience for the customer, but it's so much more efficient. In real life, you can actually take a 42 megabyte PNG image and bring it down to about 185 kilobytes. And that's at something that is quad HD. That's a quad HD image. So that's the nicest devices you can pretty much buy now, not counting the 4K ones, because that's ridiculous. Nobody can see it. It's using a lot of battery. It doesn't make any sense, right? I'm like going, well, apparently 7-inch phones are a thing now. But in this case, you can actually get what is considered 85% quality. That means you have a 15% compression applied that basically gives you almost all of the exact same quality as what you had as for the PNG file. Now, there's some downsides to that, right? So JPEG doesn't support transparency. So when we're looking at something that does support transparency, what are we also looking at? Now you're down to PNG or WebP. WebP is awesome. I just wish WebP was supported on more stuff, because most of us who live in the real world have a situation where those mobile assets have to work not only for you, Android team, but maybe also for your mobile web team and for your iPhone team. And you have to be able to design effectively, especially if you have limited resources, to make sure that that's an actual thing. I know we all are going, oh, praise WebP, and I understand it's great, but the real world sucks sometimes, and this is one of those scenarios, right? So it combines the best features of JPEG and PNG into WebP, so you get the compression and you also get the transparency. But, you know, if you have stuff that needs to go to somebody else, good luck. But let's also look at this. So there's different types of color space that you have to work with. So when we look at regular images that are stored into memory on Android, they are going to be ARGB 8888. That's just the way that they load. It always takes up the same amount of space. You save nothing on memory loading by using these smaller compressed images. They will always take up pretty much the same exact amount of memory. Doesn't matter which of these you pick. This is just helping you on transport. You need to use the bitmap options when you do loading of an image to make sure that you're using only a certain amount of memory. But I'm sure most of you guys know that because the out of memory error sucks. And it really sucks to see it on your log reports, right? And images are one of the biggest things that will cause those things to happen, especially full page images, right? And you know, somebody who's got a $50 phone, they don't really think about the fact that, well, maybe it might have some issues because it was a $50 phone. So let's think about this. If you need transparency, you basically need to look at ARGB either 4444 or 8888. 8888 is full everything, right? But what would ARGB 4444 be good at? It's really awesome at simplified iconography. Something like a lot of the material design pictures, photographs, things like that, do amazing and look exactly the same if you look at the ARGB 8888 versus the 4444. And you've just saved a ton of bits by doing so. You've essentially cut your package in half. It's awesome. But, okay, well, I don't need transparency, but I would really appreciate having all that nice little compression-y thing going on without losing anything, right? So we're not reducing the color space, we just take away transparency, and that gives you the RGB 565. So you get full color, you get all the nice gradients that you don't get in ARGB 4444, but it gives you all the same things that you would expect in a JPEG image. Just you haven't even gone to the lossy compression at this point. So if I asked you what to use on a certain thing, you now have a table that you can take to your UI UX guys and say, hey, look at this. Which one is it? So here's the too long didn't read for image filtering. Basically, JPEG whenever possible, or WebP if you're so lucky that you get your own APIs. If you have iconography, 4444 it, right? Compress all your images. I need to say this once, twice, 3 times. Compress them, okay? Everybody, as a group, compress your images. Oh, that was really lame. Come on. Everybody, I want you to believe this mantra. Compress your images. All right, and don't be afraid to use lossy formats. I know it can be a little bit daunting, and you know, if you have a UI guy who's just going, oh, this pixel looks ever so slightly little messed up or whatever. Well, you know, he's probably the only guy who's holding his phone right up to his eye. So it's okay. You can get virtually the same effect by just cutting out some of the extra that you just don't need for rendering purposes. If you're doing a photo editing app, different problem. This is not the session for you. Google Photos people do really good work on that. I don't know how well how they get that to load so nice, but I'm sure they have a lot of people doing it. And compression on the network is not compression in your heap, right? So it's going to load the same size no matter what. And you know what else? You should probably design your APIs to handle multiple screen sizes. So now we need to go to how do I make that so I can track for all those different screen sizes and networks kind of at the same time, right? So you need to adjust it based off of your network type. This is code use it. It's a broadcast receiver, tells you when stuff changes, different networks, and it gives you a little speed value, either 0, 1, 2, or 3. 3 is fast, 1 is not very fast, 0 is nothing. And it tells you, and it gives you the ability to make just a simple call. Hey, what's my network currently look like? So if you're looking at this, I mean, it sounds really cool, right? But how do you actually take this and make it look like real things, right? So if you look at that giant image on the left, those are all of the popular screen sizes in Android and their resolutions. We're not even talking about stuff that's old. This is stuff within the last 2 years. So that's a lot of different resolutions and a lot of different scales that you have to account for as a developer. Now, when you think about full-page images, ads, proportions, making the user experience feel the same between all of them, it's kind of a big deal, right? So how do I take that and condense it down to something that I can handle given to a UI guy and not having to explain a lot? Really what you can do is only worry about 3 main sizes. And this even includes your iPhone and Android and mobile web rendering pieces. It can all be convergent. You really only need to have them make it in 3 sizes. Those 3 sizes are 1536 by 1904, which is essentially your 4:3, which also works on iPad. Woohoo! Okay. Well, especially some of the older ones, it's nice. And then 1440 by 2268, and that's accounting for the nav bar. So what we have here is basically 4K with nav bar and 4K with hardware buttons. And those are just different scales. Now what's cool is that basically most of your iPhone stuff will fit into the 16:9 for quad K, quad HD scaling, and you don't have to worry about that as much. So basically your images for Samsungs, you can basically make them work on your iPhones too. So here is wonderful predetermined high, medium, and low settings for these different ratios and what devices they might be on, right? So you can actually take these values and directly integrate them into your own system. Now this was based off of what we considered in scope as far as devices go. So this is stuff that we wanted to target. We want to target really high end and we target really low end too, because we know that not every guy who works in construction wants to have a $500 phone that's going to break. You know, you drop it once, it shatters. So having something that's a little more durable, but maybe not as high performance, we still need to take care of that customer. So these values, super useful. Those are the 3 main scales. And that way you can just have it resized. You can actually script this all in something like ImageMagick so that you get all of that stuff already coming out, and your UI UX guy never even knew that he did it. So here's another technique that we need to talk about. It's called data batching. We need to put our data together when we're using mobile networks or when our users are moving around. So we can bundle it ourselves. So you wait to offload bigger data sets till the user is on Wi-Fi or some sort of bigger network, especially if you're not the main app at the time. JSON's not very efficient. XML is terrible. They've basically made these human-readable formats, which means that they have a whole bunch of extra stuff that the user doesn't care about, and that honestly, in a lot of cases, you probably don't need. But I know it's hard to get away from this because a lot of APIs use JSON. It's really easy to use. Yeah, it's really easy to use. But even CSV is more efficient. And there's already tools within Android that allow you to take advantage of some of these batch data files and binaries. Now, you can also do bundled together. And best thing to do is to do both at the same time. So you can use the GCM Network Manager and just look at their API for that in Android. And that way, it will automatically bundle your pre-bundled data in with other things so that it uses up less radio time and it better tracks against like faster networks, especially when the user isn't actively using your application. So too long, didn't read API structure. Use lower quality images and lower quality networks. Time to the user matters. You only have a few hundred milliseconds before they notice your app is slow. And they don't think about the fact, when they look at it, they think your app is slow. They don't think, hey, oh, my network sucks, or my phone is slow. That's not what the first thing in their mind is. So even if you need to get a lower quality image because you're on a lower quality network and then be able to move it to a higher quality network, when they get there and reload that image, that's fine. It's actually going to end up creating a better experience for them in the long run. Now, it's also kind of nice if you allow your users to dictate if they want this behavior. So somebody who's like an interior designer with something like the Home Depot app would maybe really care about getting really high quality images all the time. Maybe they don't want this network optimization. Giving them the ability to do that and say, well, maybe I have a really, really small data plan. Maybe I always want low quality images, right? So there's different ways that you can help get more users to continually use your app. So you need to batch your data, especially when your application is not the main application up. And use the GCM network manager. It's really easy. And even for your regular data, having it batched like that, it works pretty darn fast. So there's very few issues that I've encountered with that. So thank you, everybody. So just a special thanks to Google developers, Android Performance Patterns, and Big Android BBQ team, and Home Depot that I work for, and they let me be here, so that was pretty great. I'm not at work today, it's awesome. But yeah, so I have a question for you, and it involves prizes. So what's the name of the tool that I was talking about that makes it really easy for people who don't understand networks to understand networks? All right, you were the first guy. What? ARO? Can you actually name the full, what was the full name of it? Not just ARO, what was the full name? Okay, you'll get one, but here. You guys both get one. It's okay. Come on up. You can have. And then I'm going to ask some more questions. Yes, it is. Thank you. All right. So, if you were paying attention fairly recently, how many aspect ratios do you actually need to care about for your images? 3. Well, don't just say it. Okay. 3. Okay, there you go. Okay, so if I'm looking at this correctly, what's my TLDR? Okay. What image format should you be using for a majority of your images that don't require transparency? So you gentlemen were right. Yes, you were the first to raise your hand. Or, well, you're correct either way. So, or JPEG or WebP. So I would accept all 3. But this one's got your name on it, buddy. And everybody gets a Home Depot like foam football over here. So everybody wins. This is America, apparently. We're all winner. All right, sir. So what's the name of a certain API within Android that makes it really easy for you to bundle all your data? Guy in the far back. You win, sir. The final one is for you. So does anybody have any questions? Oh, wow. Okay, lots of questions. You, sir? You're going to have to repeat that. So I have looked at that a little bit. It really, So yes, I have. It's just that having that implemented, I'm unaware of anybody who's actually like moving towards that at this point. So, I mean, it'd be nice, but it's just not happened at this stage, I don't think. All right, any other questions? Yes, it's defined by that because it's hard to pull data from as to what your exact speed on that network is at that point. There's some tools that allow you to do that, and I've also done direct tracking. So for those numbers, those are based off of me basically using NUTTCP to test against my own servers to see, okay, what does this look like? What does that look like? Where possible, but it's very, unless you have something that's constantly pinging, you're never going to know exactly what time responses and how quickly something's moving without actually, this you get for free. This is information that's broadcast by the system and that you can just plop it in and you can immediately make the best inference that you can as far as the network quality goes. And also be pretty smart when it comes to how you're actually putting stuff together. So my average speed when we were using the application was only like 43 kilobytes per second. That's pretty small, right? So that means that could actually, I've made it so that I'm not constantly hitting big numbers and I'm using as little network as I can, even though I was on a super high quality network, right? By condensing things, I'm able to make that happen. See, you can do both. This is basically just and if you have something that's critical like that, it's probably best to do both, but it's extra computational overhead, and something like this allows you to, especially when you're not the primary network, not the primary application up, maybe you're just making sure that user session stays active, or you're passing back just some metrics that you collected while they were actually using the application, but maybe you didn't want to interfere with the application being used at the time. So by kind of understanding that, hey, I'm not on a great quality network, I'm going to wait until I see this number pop up, then I'm going to try and shoot it, right? And you can also use Job Scheduler to kind of help with some of that too. This is just kind of, there's a whole bunch of sessions that Google has done on Job Scheduler that you might find really, really nice. And actually, I really want to go to Joanna's Doze thing at some point, but I know it's like happening at the same time. But does that kind of answer your question a little bit? All right, cool. Any other questions? So I've found that WebP quality is a little bit higher than regular JPEG, but I think it also depends on what compressor you use on your JPEG. I'm not super great at knowing like everything. So I'm a little bit of a pixel fiend, so I'm definitely like, we have to have high quality assets. But at the same point in time, you have to determine what is worth the quality and what isn't. So maybe a square that's just like a background square, maybe that doesn't need to be like a high quality square, you know? But maybe something where it's like a picture of a product or a picture of somebody, that needs to be high quality. So you need to kind of determine what that needs to be based off of how it's being contextually used. And it's always different in different organizations too. So retail, always make the product look good. Signage, look pretty good, but it doesn't have to look nearly as good as the product does. The product has to look like, oh man, I want it so bad, you know? So there's just different ways you have to handle it based off of that. Any other questions? Yay! All right, what is the mantra? Compress your images. Everybody compress them. So thank you so much for coming, and I super appreciate it. You can feel free to come up and ask me anything else if you wanted to privately.